scientists of Reddit, what's a phenomenon in your field that the average person hasn't heard of, that would blow their mind? Just started a PhD in astrobiology. Does that make me a scientist? Looking at microbe behavior in low gravity environments. It turns out that microgravity has a tendency to make microbe populations into these superbugs that are incredibly resistant to antibiotics. There's some worry that this will be a pretty big problem as human space exploration develops. C-section babies are, on average, less healthy and have more compromised immune systems. This is likely because the birth canal is smearing the last bit of mom's immune system programming before breast milk, as well as helping create a healthy bacterial environment for the newborn. Essentially, a mother's veal walls are coated in things that will help the baby adjust to life outside the womb. C-section babies are starting to get the benefits of this by wiping mom's veal wall fluids onto the baby's face and mouth and head. Edit. Added on average. The lab I work in developed a way to record the vibrations a caterpillar produces when feeding on a leaf. We have found that plants are able to respond to this vibration when it is played back to them. It not only primes their defenses, but they can distinguish this vibration from vibrations caused by wind blowing, insects walking on them, insect mating calls, etc., and they will not prime their defenses to those vibrations. TLDR. Plants don't have ears, but they can still hear. NPR hosted my professor for a segment. Edit. First gold. Thank you, stranger. Schultz Apple Lab website W publication links. Yevon's paradox. The more energy efficient we make technology, the more energy we actually use. It's not exactly mind-blowing, but it's a neat and recent finding that might interest anyone who keeps up with the vaccine topic. Post-mortem brain examination of kids with autism has shown improper cortical distribution. A little background. The layers of your cortex are established very specifically before birth. If you have a healthy brain, you'll exit your mother with clearly defined cortical distribution, and that layer differentiation does not continue post-birth. Thus, we can conclude that the disrupted cortex structure being found in autistic children cannot be attributed to vaccines which are administered after birth. Furthermore, we can also conclude that autism begins affecting children in the womb. For reference, cortical and cortex are synonymous. Here's a bit of psychology. Since the harder sciences are well represented, specifically relationship psychology, it's been demonstrated that there's a particular ratio of positive to negative interactions that help predict the outcome of relationships. Marriages with less than this ratio are far more likely to lead to a divorce. The ratio is roughly 5 to 1. For example, if there are less than 5 compliments you give your significant other for every 1 criticism, then they're more likely to believe that you criticize them more than compliment them. If you have less than 5 good days a week with your so for every 1 bad day, then when you think back over your months or years together, you're more likely to think that you have an equal amount of bad days than good, or even more bad days than good. The mind-blowing part is really thinking about that ratio and what it means about our memory and perspectives. Ideally, we'd like to think that if we get complimented about as often as we're criticized, we remember a balanced mix of both. But the evidence supports the idea that we really take negative words or events to heart, and that it takes a highly disproportionate amount of positive praise or interactions to balance them out. Something to keep in mind when considering both how you feel and how you treat others. Geneticist here. Different people have different forms of various enzymes, meaning that medication is horribly, awfully imprecise and affects people differently. For example, some people break down codeine into morphine very quickly, which can result in overdose, and some don't hardly at all, so there's no pain-killing effect. Until very recently, there was no way to know but to try it. This is a pretty good review. My research involves Parkinson's disease, and recently there's been findings that contracting an infection such as flu whilst having PD will make the disease progress much faster, as your immune system will kill the brain cells responsible, in a kind of accidental collateral damage response. So we're looking at how some anti-inflammatories could slow the progress of PD by stopping infections from taking their toll. Early days though, but very promising. Pretty much everything about sleep is terrifying. Most of all that we don't really know what it is or why we do it or how it works. Why do you sleep? Because you get tired. How do you sleep? Well, here's a list of things that change while you sleep. What is sleep? When you want to wake. What I find most disturbing is sleepwalking parasomnias. Watching people sit up during a sleep study and seeing that they're still asleep, opening their eyes, looking around, and then usually they pick at the wires, maybe lifting them up and tugging gently on them or touching where they are placed on their heads. That's not the creepy part. The creepy part is that they don't pull them off or anything. Instead, I have so far only ever seen them all do the same thing. They give up. Like, you can read the facial expression saying duck it. This is too complicated for me to deal with. And they just lie back down and don't go back to sleep because they didn't wake up. They just close their eyes. It's not that the lights are on but nobody is home. It's the lights are on but you aren't in there. I mean, I'm not really a scientist, I'm just a lab tech. So maybe there's an explanation that makes it less disturbing. There is a documentary that has been released lately and it's called Most Likely to Succeed. It's about a new education method where it is 90% project based. The teachers don't do much other than just let the students do their projects and give guidance, as well as organize what projects to do. It's a unique way of teaching that only works in specific schools. Some teachers, members of society, think it's the greatest idea and every school should be using it. Me and other teachers don't see it as straightforward as it seems to be. I recommend giving it a watch though. Edit. Also, I know teaching isn't science but thought this was worth including anyway. Malaria parasites have shown resistance to every single anti-malarial drug in existence and can develop resistance before new drugs are even finished in trials. Not that there is a big push for anti-malarial drug development. Last I checked there were 7 new drugs for erectile dysfunction in the pipeline for every anti-malarial, and 64 drugs for heart disease, a problem a lot of people in malaria endemic countries would like to live to have. Everyone always associates dopamine with enjoyable experiences or happiness, but in a certain part of the brain, how much dopamine is released can be calculated as amount of reward received, amount of reward expected. This is literally a quantitative signal. If you expected there to be 10 sweets in the bag but there were actually 12, then you'll get an increase in dopamine release but not as much as if there were 14 sweets in the bag. Similarly, if you expected 10 and only received 8, you'd actually get a dip in the dopamine signal, but not as much as if you'd only received 6, etc. This is one of those rare examples where a quantitative theory or model, reinforcement learning, can be mapped straight onto a neuroscientific phenomenon. Dialect continuums in linguistics. Among certain languages such as the Slavic languages and the Western Romance languages, Portuguese, Galician, Spanish, Catalan, etc., there is no fine line from where one language ends and another begins. However, due to standardization this is largely no longer the case. Instead, you would have one language gradually changing into another as you go farther and farther away. Think of it like in Britain where the farther north you go the more Scottish the dialect becomes, until eventually you have full-on Scots. Feto-maternal transfer. I learned about it in a neuroscience class. Essentially, when a woman is pregnant, stem cells can travel from the fetus to the mother and actually survive for long periods of time in the hippocampus, an area of the brain used for memory formation. I'm pretty sure the stem cells can survive in other parts of the body, but it's really cool to think that some of your DNA is in the part of your mother's brain where new memories are formed. TLDR stem cells from a fetus can get transferred to the mother's hippocampus, the part of the brain responsible for forming new memories. That a sound pressure level of 0 dB doesn't mean no sound. Not a scientist, but Cherenkov radiation is really ducking cool. When electrons travel faster than the speed of light does in water, it gives off an awesome blue glow around nuclear reactors. Google it for some really cool images. Power industry. Power quality and the relation of real and reactive power is pretty neat. Imagine electricity is like beer. Real power is the liquid. Reactive power is the foam. You don't want your beer flat, but you also don't want a glass full of foam. Reddit is pretty high on wind energy, but one major issue is wind turbines eat up reactive power without providing much into the grid. You have to compensate for it with really expensive, complicated capacitor banks or other means to provide reactive power. I think it's pretty fascinating. Flashover and backdrafts are pretty cool. Basically, flashover is when you get to a point in a compartment with a set amount of ventilation where the heat release rate of the fire reaches a certain kilowatt and every combustible in the room ignites almost simultaneously. It's really ducking hot and it's really bad to be caught in. Here's an example beginning at about 4:55. Backdraft is when there is a lack of oxygen in a compartment with no ventilation. The hot gases build and then when oxygen is reintroduced to the building it explodes in what is basically a fireball, violently. Here is an example at about 35 seconds in. Put simply, you can see with pretty good confidence what a chemical compound is by throwing some light at it and seeing what wavelengths come back. Tropospheric ducting. Shortwave radio signals, up to about 30 MHz, bounce off a layer of charged particles in the atmosphere and are reflected back down to Earth. Which is why you hear so many AM stations at night. Normally higher frequencies just poke straight through and go out into space. But under certain conditions they pass through a gap in one layer, hit another, and bounce along between the two like when you get the ball trapped behind the bricks in Arkanoid. Until eventually it bounces back out hundreds of miles away with almost no loss. So, by a sheer accident of meteorology you can sometimes bounce VHF and UHF signals far further than they normally go. And they sound like they're from just down the road. Surface science. Van der Waals forces between materials are almost universally attractive. But it is possible to create a 3-material stack of a surface, intermediate, a liquid or potentially a thin film, and contacting material that has a repulsive interaction, meaning that the surface and contacting material will repel each other like two north ends of a magnet. Applications would include surfaces that would be water, oil, dirt, biohazard, whatever proof and frictionless interfaces, tested by AFM and undetectable at the piconewton level. Unfortunately the thin films required are not easy or cheap to make and development would be $. This is probably going to get buried, but it's my lab's time to shine. I have a good one and a bad one. Bad, more than 2 out of every 3 people in the world carry a virus that causes oral genital herpes, HSV 1 and 2. Good, if you genetically remove one of HSV's key genes, GD, you get a vaccine strain that's protected mice against 10x the lethal dose of the deadliest herpes strains ever discovered. TL. Doctor, everyone might have herpes, but it won't always be forever. Meteorologist here. Upper atmospheric lightning is one of the most seldom understood aspects of meteorology. Above some thunderstorms, sometimes you can spot a jet of blue shooting up from the thunderstorm about 50 kilometers. Even more impressive are sprites. Giant red emissions anywhere from 50 kilometers to 100 kilometers above the surface. Elves are even crazier. They exist for only a millisecond, but expand to a radius of 400 kilometers from a storm as a very faint red light. Crazy stuff. You can see the most well-documented sprites and blue jets here and here. Not quite mind-blowing but definitely exciting. We now have microscopes that can achieve resolution in the low nm range in living cells. We can now start to research the dynamics of small subcellular organelles that are important for a wide range of things, such as embryonic development, cancer progression and cell signaling. This will almost certainly get buried. But what the hell? Trees suck up water. Most people know that. But what blows my mind is that they don't have to be alive to do it. Dead standing trees still suck up water. It's a structural component, not an active function of the living organism. Also, there's way more water from snow melt than we ever thought there was stored in trees based on a recent isotopic study of Alaska forests. Not sure if it's published yet, but if folks are curious I could find out at it. Here's the paper. So a lot of our global water cycle budgets are probably wrong, and that's kind of big. I'm a dentistry student, and yesterday a paper was published where a group of scientists managed to use an anti-Alzheimer drug in order to build new dentin and damaged teeth. Pulp tissues are already capable of doing that, but research is desperately trying to find agents that can speed up the process. So this is great news. I'm an earthquake geophysicist. I study something most people have never heard of, slow earthquakes. In a regular earthquake, a fault, a crack between big pieces of rock, moves, or slips very quickly. Typically an earthquake takes a few seconds to occur. This rapid movement excites seismic waves, which are similar to sound waves that travel through the earth and cause shaking. In slow earthquakes, everything is the same except that high temperatures and or fluid pressures cause the speed of fault slip to max out at a fairly low value. So we might get movement equivalent to what we would see in magnitude 7 earthquake, but instead of occurring over seconds it occurs over weeks, months, or even years. The slowness means no seismic waves and no damage. In fact, the traditional instrument used to study earthquakes, the seismometer, won't see these. So we use scientific grade GPS instead and literally watch the rocks move. Unfortunately, slow earthquakes, while they relieve the forces where they occur, actually increase the probability of regular earthquakes on other faults or other parts of the same fault. There are documented cases of slow earthquakes triggering regular ones. The Great Tohoku, Japan earthquake of 2011 actually started off 2 weeks earlier with a slow earthquake. I'm working on trying to find ways to use slow earthquakes to forecast regular ones. Not a scientist, but an author. But I do have a mind-blowing fact related to my field. There are only about 20 different plots in almost all of fiction. With very few exceptions, all stories are one of those 20 master plots, or made by combining up to 3 of them in sequence. Why? Because the real meat of a story isn't the plot, it's the interplay between characters and the setting. You may notice how almost every action film has effectively the same plot. An underdog most face off against a threatening force with little to no help. They emerge triumphant and gain fame and glory. The only reason you see a difference between RoboCop and basically any John Wayne movie is 100% the characters and the setting. They are otherwise the exact same. If you know this, and you also know the basic character archetypes and typical tropes of the standard genres of fiction, you will never be able to enjoy a movie again, as after 5 minutes you'll be able to work out what happens in the movie, how, and to whom. This is due to cinema being extremely formulaic. Galaxy lensing. I think it's just beautiful. Just like the way a magnifying glass works to make things appear bigger. Large chunks of mass in our universe, that is, galaxies, have a strong gravitational pull over large amounts of space that focuses light, giving a distorted look which leads to some special cases results in a Reinstein ring. But not all cases result in this amazing picture. This phenomenon has been used to probe universe and can give good insight into finding better measurements on Hubble constant without local contamination like many other methods. Julius Wagner Jauregg won the Nobel Prize in Medicine for treating people with syphilis by giving them malaria. Something mathematical, but I is a real number. I equals sqrt minus 1 is an imaginary number. Many animals use the location of the sun in the sky for navigational purposes. Many, fewer, animals use the way sunlight is polarized as a proxy for the location of the sun in the sky. This allows for a mental compass and is how many animals keep moving in their required direction. Many, although fewer, animals also use the moon for the same purpose. However, only one known species, the dung beetle, uses the way the moon's light is polarized to keep rolling their dung in straight lines. However, when the moon is absent from the sky, the beetles default to using the location of the Milky Way in the sky for navigation. 15 days of the month of August-October, from the equator, have both the moon and Milky Way out of vision of the beetles. For these 15 days, they roll in almost random directions, during turning frequently and just generally looking drunk. Edit. Typo during more than turning and August more than October. That when I refer to a wiggly hypersurface when presenting my statistics, I'm not bulleting at all.